and welcome back once again for yet another video about the discrete time Fourier transform. Now, I should have actually started with this example because it's extremely simple, but my mind is complicated and I didn't actually think about starting from the very simple basics. So sorry about that. So what's today's exercise? Well, today's exercise is actually very simple. It's where you're asking us what's the discrete time Fourier transform of the delta. So what it means is basically they want to know what's the discrete time Fourier transform of delta of n. So what do we do? As always, we start from the definition. So what's the definition once again? Well, the definition is x of e to the j omega equal to the sum of n that goes from negative infinity to positive infinity of x of n e to the negative j omega n. Now, just like in the other occasion, we basically we didn't have the delta, we had the unit step function, and we basically integrated this inside the sum, and to get rid of this, and then calculate whatever was x of n. Now in this time, this time we're essentially going to do the same, but it's even going to be easier than that. Why? Well, what's the delta? Well, delta is actually the thing that I'm going to show you. It's actually defined as 0 everywhere except as 0 where it's 1. So as 0 is actually 1, but other than that, everywhere else is just 0. So it's 0 everywhere except for 0 where it's 1. What does it mean? Well, it basically means that this sum is not a sum. Let me just elaborate that. Capital F, x of e to the j omega equal the sum of n that goes from negative infinity or positive infinity of delta of n e to the negative j omega n. Now this sum is not a sum because everywhere the delta is actually 0 everywhere except at 0 where it's 1. So it makes sense to evaluate this whole thing only when n is equal to 0. So what I'm saying is that instead of having this sum, we can easily write e to the negative j omega n evaluated when n is equal to 0. And this is a piece of cake because right now we just have to substitute n with 0. So we got x of e to the j omega equal to e to the negative j omega times 0. And this is fairly easy because right now that we have this, we basically have x of e to the j omega equal to something times 0, which is e to the 0, because 0 is going to bring j and omega to 0. So e to the 0 is just one, any number to raised to the power of 0. So the number a number raised to the power of 0 just 1. So in this case, x of e to the j omega is 1. So the discrete time Fourier transform of the delta is 1 for this very reason.